Hey. I got a new screen overlay, so I can talk while we're doing this. Yay. Hey, everyone. It's me right in the corner. Full screen? Yeah, sure. Hey. Oh what? I've got music on. So I've decided to put music on so I can hear music, but I can't play it back because copyright laws, which is not great. Also changed the what do you call it? The webcam. It's a bit different now. Anyway, hey, what's going on? Today we're just gonna work on some stuff. I'm not quite sure what. I think I would start off with nano component with figuring out how to cache these things, and yeah, that's about it. That's about it for today. Yeah. So that's my story. There's nothing much. What's the date today? I think today is March 4th. Today is March 5th. Monday, March 5th, 2018. And welcome everyone. Is there anyone here? There's nobody here? Nobody? Just me? Oh, one person. Hey, welcome electrical skateboard. All right. So, what I'm thinking is there's this one big issue with CHOO. Haven't touched CHOO directly in like a week or two now. I've been working on nano component a little bit. I've been doing like some other stuff, just doing research. But we really need to fix some of this because there's some stuff that's like not going the way it should. Yeah, there's a few too many open PRs. Whoops. Probably also change that. All right. So the idea is we have this module. Okay, so we have two modules. Hey, Colin, welcome. Nice to have you back. The idea is you've got this module called nano component, which is a component abstraction. It's just a class thingy where you implement methods on it. It's pretty straightforward. And then you have CHOO, which just re-renders this whole thing. And then you want to use this inside of this, but you need to cache it. How is that? You need to preserve an instance on re-renders, where this create, like we call this method all the time. I'm not doing a good job by explaining this. Colin says, I'll mostly be lurking. Yeah, that's all right. Happy you're like hanging out though. I like that. I appreciate it. Yeah. Oh, I should do a good job at explaining what's going on here because this is really annoying. It's important to get right. Foo.js, fine. Let's open a new file, right? So if we call a function, right? So function render, and we say return foo. Every time we call render, all of these instances will call this function, and everything that happens inside of this function will be recreated. So this string of foo will never refer to the same place in memory. It will always return a new string. So it's a new allocation, does a bit of computation to figure out what it is. Maybe if V8 is smart enough, it'll be like, hey, you know what? We can always refer to the same thing because it's a static thing. But for example, if we switched it up a little bit, right? Like this will always create a new allocation. So each of these methods is going to be not great. Now, var prefix equals foo. Now say if we wanted to do this, prefix plus new date, then you always want to move this outside of the scope because this static thing, and we want to keep this instance around so we don't reallocate it every single time. And then we can append it here. Now V8 is generally smart about most of these things, but not always. Like in the case of components, it gets different. So let's just pretend that this string, like it's that way. So if we did this, under the hood, it would always allocate this new string, and then it would like do this thing, and it's not great. So we want to move it into the outside scope. Same happens with components. say var component. Let's just pretend it's just an object, right? Let's pretend this is magical object or new component or something like that, right? Where component is required /component/button or something like that. Then what we want to do is we want to make sure we don't recreate the whole component on each render cycle, but we just call its render method, and we can keep the instance around. I'm just gonna pour some water while this micro break goes on. There's more than a few reasons why this is a tricky thing to do with DOM nodes directly, and why it is a tricky thing to do with CHOO especially. But yeah, so component/button. Let's rename this to button, and this is our button, right? Our button. Now, what we want to do similarly is return our button.render, right? So if we did this, we would be allocating a new button on every single render, whereas in the other case, we just call the one method, which is overhead, but it's way less overhead because we're not recreating an instance on every single render call. And this gives us the opportunity to, I don't know, some props or something, where it just returns a reference to the existing thing along those lines. So we optimize it, it becomes faster. Related to that, if, for example, our button on every single instance creation would be doing HTTP calls, it can be very subtle, like referencing an image on the server, and the image doesn't have the right cache header set. It will trigger an HTTP call every single time that we call a render function. And if our render function is like a giant tree, you know, we're suddenly getting all this overhead, and people are like, oh God, why is our network congested? And you like look in the inspector and you don't understand what's going on. So that's not ideal. Oh wait, I should actually mention this. Yeah. Anyway, so the goal, what you want is you want to have this, right? But say we have a couple of views. Oh, hey Shelto, you're welcome. And thanks for the feedback. View 1, and then we copy this, right? Oh, fuck. Like that. Then we have view 2 and view 3. R3, please. Yeah, okay, there we go. Right. And then instead of here, we basically make a switch. Fuck it, I'm not gonna type this whole thing out. View 1, view 2, view 3. Along those lines, right? Like if else conditionals. There should be some type of if state, type 1, do this, or if route, if state.route, whatever, right? In CHOO's case, we would do app.route. Yeah, but the main point I want to illustrate here is that if these are all separate files, all of these, right? Then what would happen is actually what you want to do. Let's rename button to header. Header our header.render, right? For example, you might want to like do something along the lines of a header and then like some body and then like a footer, right? You would want to reuse this instance here at the top for every single one of these instead of recreating them the moment you switch a view. So that gives us a problem because we need to reuse instances in between files. In an ideal situation, like if we're really gonna do it right, and if we're like really gonna reuse all the stuff that we can reuse, we need to reuse that too. So that brings us to the following problem. How do we reuse that stuff? Now, we kicked off a whole discussion about this, and it's been going on for like way too long. Components. Discussion to October, September, October, November, December, January, February, March. So this is almost like 5 months ago, 73 comments on this thread. 21 days ago is the last one, right? It's too long. Like Brett has had some really good input. Right, I should have like taken this up way sooner. Anyway, we need to find a good way to do something now. the problem, so the place where we left this, I think, was so Brett has a thing. I don't like that thing that much, personally. I feel like it's not too ergonomic. I can show it for a bit, but this is my personal opinion. No ill will intended towards Brett because he's done like some really great work. It's yeah. there's just like some subtleties. Oh god. Becomes component cache. There we go. Components, component cache. Package, GitHub, morph leak. There we go. Now component cache. So there's some stuff going on here, right? He has the now component cache. He makes a cache, and there's a bunch of stuff going on. There's a GC argument, there's an args argument, there's an LRU stuff. I don't know what all that means. There's the register step, there's the unregister step, there's the get, there's the set, there's the GC, there's the clear, there's the delete, there's the has. I feel there's too many methods for it to be like really ergonomic, because what you really want to do is you want to have two steps, two explicit methods. The first explicit method is a getter, is get, which also includes a set, and the other one's a what's the other one? I don't think there's another one actually. There's the under the hood delete version of it. Yeah, that's basically the gist of it. Actually, all we need is like one method, and then this cache thing is backed by a LRU cache called Nano LRU, I think, which another person wrote, which is really cool. Oh, class cache. No, it's not. But there's also Nano. I need to find coherence in this story. The idea is you get automatic LRU, because if you're writing a cache, you need to clean up your references every now and then, because if you're walking a list on every single re-render call, that's gonna be really expensive. So instead, you can hold a little bit more memory and just evict things when it's convenient. So that requires some tweakage at times, but it's generally fine. So the idea here is that we can do that. Yeah. So we need to create a cache thing with the LRU backed with just one method instead of multiple methods, I think. So I made a proposal somewhere. I forgot what it's like. There. We had a call about this today. Oh god, I forgot. I should also not be removing the thing. Oh yeah, basically that we can do this API. When was this called? 2 months ago. Fuck. So you can pass out LRU stuff and get this dot local to do this dot cache dot get kind of basically. So you get the thing, you pass it the instance of the thing that you want, and then you pass it an identifier. Ideally, this would be automatic. I think. So you get, and then you like render it, which is reasonable. Right. Let me just think. I haven't figured this out yet, so I'm thinking while talking on stream. So if I grow silent for too long, just drop a comment, be like, hey, hello. Stream to Yash, are you still around? Because we need to figure this out. So this API is like slightly verbose, but it's not half bad. So ideally we could just like go for this, and then someone just does this thing, which I think is reasonable. I think it's reasonable as a first step. So let's do that. Let's actually build that cache and get that working, and have that doing stuff. Oh, there's also another thing. I have this nano cache. Oh, there we go. Nano cache. What does it say? What is it? Yeah, there we go. Attribute.js nano cache. What we want to be doing here is in this case it class article example.js cache component. No. Component preview. Here we go. 3 months ago, way too long. The idea in this one is that we have state, emit, and render, where render is the cache thing, which is not great. So so is this case just for now component? Shelter asks, and the answer is yes. I mean, it doesn't include state data. So component instances themselves have state data, and you cache an instance. So there's data on the instance that you cache, and that's the extent of it. Because you're caching stateful stuff, right? Hope that makes sense. All right. So this is like a really concise syntax, but turned out to be magic-y. Whereas this is less concise syntax, right? But it's a lot less magic-y, which is good, which is really good. Yeah. So yeah, people really want it this other way, which I'm like, okay, yeah, you know what, fuck it, fine. Let's just do that. Let's do the least magic-y, perhaps not the most ergonomic way of doing stuff, but ergonomic enough because there's just like one method. Yeah. So what I'm thinking of doing is creating state.cache instead of passing like a third argument, because the I don't know, the third argument feels very intrusive. It's like, hey, here's this extra thing, and then we would also need to cut out a slice of state for the thing. I don't know. It just feels weird. It just feels really weird. Anyway, so we can do this .state .cache, and then that's our getter. That's just our getter, right? Single method, nothing else. And then we just pass it. So it would look like this .local.todos.map to do this .state.cache to do .id, which is a static method, .render to do. Is this the best? It's pretty straightforward. So we have this .local, it's a vanilla component. Instead of this .cache.get, we just say this .state.cache, and then we pass the rest of the arguments. Once you see it with the boilerplate included, it probably makes sense. It probably feels okay-ish. Yeah, so let's build that. Yeah, so the idea is that this becomes a bit like this. Let's say cache could be like really ergonomic, and then people slice out. Okay, more words will not help here. More words is mostly just for my own brain and my own understanding of this stuff. Right. So nano true component preview. Let's open this in GitHub, see if there's any open issues, which they're not, which is great. So there's two things that we want to do. Actually, we can start off by Travis.js hook, which Travis.js yeah, we just hook it in there. So now we can do we skip this? Actually, my wrist is not doing too great, but I think if we just respect the tiny breaks, we'll be fine. So we can try this again. This registers the thing on Travis because apparently it wasn't yet, which is good. There we go. I accidentally spilled coffee in places. Shaking around my coffee cup. That's not recommended. Turns out coffee spills. Who would have thought? So one thing I'm doing is update this thing to just use the API that we proposed. proposed, right? Oh, I keep forgetting this, but I need to show you a fun trick to JSON. JSON string file to JSON MDN. That's the one. To JSON. I didn't know about this until a couple weeks ago. That was making me so happy. So whenever you call JSON stringify, JSON stringify under the hood, whenever it touches an object, it will call its toJSON method. And by default, that's like some built-in C++ thing, which just does the thing you're like used to. But you can overload it, you can overwrite it on the prototype, just or on the instance, which means stuff that isn't usually serializable. For example, you can't serialize a function; you'll just get like a E error or something obscure like that. So yeah, actually, I can show you this. Node JSON.stringify function, right? I was just like, oh god, it doesn't return anything, right? So foo function, it might just like blow up. I hope it does. No, it just returns empty, which is not ideal. Or it might like do the instance stuff, and it's just not great. So instead, if you specify toJSON, it just does a better thing. It just makes it a little bit better. I know it gets passed though. If an object being stringify has a property in toJSON whose value is a function, then toJSON method customizes JSON stringification. Instead of the object being serialized, the value returned to toJSON method will be JSON stringify calls toJSON with one parameter. Cool. If this object is a property value, the property name, that's cool. If it is an empty array, the index in the array as a string. Cool. Also cool. Double cool. Oh, hey. What operating system do you use? I use Linux. Specifically Arch, but that doesn't matter too much. Why? Because I took the plunge in December. I was like, hey, you know what? I'm not liking all this Apple hardware. Apple hardware seems to like, I don't know, they don't seem to be caring that much about laptop users or desktop users. And I was just unhappy, and I was like, all the production systems that anyone ever builds, they're never on OS X. They're always on Linux. So I might as well just like switch that full time, because it means I get to learn more about Linux, which means I get to be better at jobs. It's also fun to customize. That's like free software and all the other stuff. But the main reason was I just like got bored with Apple stuff. So yeah, what you're looking at is just a good old Linux desktop. Thanks. Yeah, you're welcome. No worries. Oh, I'm just gonna stand up for a bit. Oh, come on, camera. Can you all see me? I hope so. Yeah. all right. So the reason why I'm bringing this toJSON stuff up is because on this side of the pond, God, this side, somewhere. So, oh yeah, this state.cache, you wouldn't want to like stringify the cache itself. So that's a no-no. I burp a lot. I'm a human being that burps a lot. Too much. I don't know. Too much? I don't know. I try to be polite about it. Maybe that's the thing. Maybe just notice because I don't know. I don't know why I notice. Maybe I drink too much water. Maybe I'm just too hydrated and my belly balloons and that's why I burp. I'm not a biologist, physician, whatever it's called in English. I do not know the word for a person that knows biology. Anyway. Oh, who's in their room? Actually, let's check it out. There's 5 people here. Hey, everyone. beavered, fleshy. Welcome everyone. Right, computers. Okay, we're gonna build this thing. So let's update this thing. We just changed our branch name proposed. What's our diff? There's no diff. npm runs npm no test. We might need to call npm install because we can't find standard and some other stuff, so we're just like running this. So hopefully this resolves all right. We're getting lots of 304s, which is great because that means our cache is nicely saturated. I hope the stream doesn't lag. That would suck. Apparently we're also getting bcrypt down, which I don't know why, but that's okay. Anyway, so let's take a look. What's going on here? We got this store thing, we got the state emitter and app get passed in, which is all fine and dandy. Var set route, app.route bind, that's okay. Oh, hold on. Is that okay? No, that's not okay. Flashy. I came for the Vim, GVim now. I stay for the burps. You're happy to provide either Vim stuff or burps. All right. Oh, so for those of you that don't read my tweets, which is probably most of you, I switched to GVim from Vim yesterday, which replaces the Vim command because I couldn't copy paste, and now I can copy paste. It's really good being able to just be like, oh my god, copy and paste, and then it actually copies your clipboard. So if you do xclip-out, it actually, you know, the thing we just copied here just appeared there. It's amazing, and you don't think about it on other operating systems because it's been solved for you. But not on Linux. No. You get to solve it yourself and figure it out and cry a little. That's okay. We don't cry. Not about this. Cry about other things. Anyway, so here's the thing we don't need to do. We no longer. All right. So the changes we need to make here is we no longer need to overload app.route. We can still create a cache. That's fine. We have lib/cache. That's all okay. We need to replace that with a GC thing, which is also okay. Yeah. That's about the extent of it. I think. Cache.render.apply stuff. Yeah. So our API changes. So set route is no longer needed. App.route is no longer needed. Emitter.on state events render cleanup. So this is our cleanup function. Replace with what's that? LRU cache. That's a to-do for today. Var cache. So we're not using cache. It will give us a warning. It says, "Oh, render is defined but never used." Oh, lol. Cache render args cache.render.apply cache args. Oh yeah, this is our render function. I think we pass as the third argument here, right? So we overload the thing and now we have a render function. So what we want to do is this is called once, just on whenever, right? Emitter.on. So what we want to do is here state.cache equals render. And now we have a render function available to us. Example index. All right. example view. So we can no longer do this because that doesn't exist. Instead, we need to do, not that, state.render. Sorry, state.cache. Like that. State.cache, header, footer, right? Example like there, and then we have a component over here, and then do we have a cache? No, we don't. Other, yep, again. And then we go back here, state.render, oh. Cache, component, and footer. Oh, wait, hold on. Component has a stack identity. Let's rename this to ID. Component.id, and what do we do with that? We pass it a name. Other, header, footer. I'm a bit annoyed by this. Other, ID, header. It feels very repetitive. I don't like the repetitiveness of that. ID, footer. Right, that feels yucky. People might look at this and they're like, holy shit, this is what it takes to use components. I don't want to use components anymore. It's too verbose, and I fully agree with that. All right, what I'm thinking is we default to you can. So I want to keep people happy that do want to do this, even though I don't necessarily think it's a great idea. Because that's been the main point of contention. People were like, oh, it needs to be explicit. And I was like, yeah, but it's not nice to type. It's too much typing. If you're building something, you want to build something fast, and this like takes all the joy out of your lungs. So you know what? We're going to revert that. This is how I do API design. Like, hey, can I type this out in a single go without like needing to think about it? And if the answer is no, then we don't do it. So stack ID, right? So we just pass it like that, and then we go to our index.js file, and we have render. Cache.apply, cache.render apply cache args. So that should be a case. It should be the get cache.render.apply.get, I believe. We ditched the render method. This will simply not work, by the way. It only takes one argument, or maybe it takes two arguments. Var args component. It takes the ID and it takes the what's the second thing? Component ID other. Oh, actually, if we redo this, then all it does here is it does that. Yeah, it's not okay. I can live with this. This is the identification function. That's okay. That's okay. I was afraid that we had to double type a thing. All right. So this is reasonable. Then we can ditch this whole thing, and we do component. Let me pass the ID. Yay. Return cache.get.apply. Just cache.get. No need to apply anything. We pass a component and we pass the ID, and then we return that result, and then we say dot render on the result, right? Dot render, no, dot render. Now we do it for all of these. Am I happy about this? Just feel, all of these feel gross. Is this okay? Is this explicit? Yeah, it's hell yes, it's explicit. Do I like it? I don't know. I am not sure. I'm not sure if I like it. Because what we're doing here is we're giving it the thing, and then we're giving it a name, and we could just also statically do this thing, and actually that might just be better. If it doesn't need an ID function, you just statically pass it the property for the cache lookup. That's a good point. Thank you for pointing that out. So there's no point in doing any of this, right? So we just statically give it the identifier. And because this string will just get optimized by V8 because it's a static string, it's always called, so should be fine. Like this overhead won't kill us. Yeah, this is reasonable. So we say, hey, state.cache, here's the component you want to render. Here's the identifier for this component. Please render. And we just apply it on to state.cache. I think people might want to use this. This is straightforward enough that people can remember it. 2 arguments, and it gives you a thing, and if you're not sure what it gives you, you can just inspect it and you'll never make that mistake again. And then you have .render on it, and that also works, right? You just call .render and you pass it the arguments you're used to. So in this case, for the constructor, how does that work again? I forget. God damn it. Okay, so here problem. When you're doing this thing, you will want to pass it a constructor thing. All right, let me just think for a second. All right. This is the problem of API design. You're literally like, oh God, here's an edge case, here's an edge case, here's an edge case, and looking at the process is the hard part, and looking at the end result. You want to have something that's easy to use for people, where they don't go like, oh God, I'm so constrained by this, or there's too many words that we need to learn. There's a lot. I feel a lot of APIs. They introduce a lot of words, a lot of concepts. Concepts, it's the wrong word. Better phrase for this is they have a particular view. Let's pick on Redux for a little bit, right? Because it's sort of the de facto thing in front end world right now. It's what people have agreed on is the way you should be building applications of one of the largest frameworks out there right now, and it's not really been overthrown. People still think it's a really good idea, but there's other people that are like, yeah, I'm not really comfortable with this. I'm one of those people, and I feel, I appreciate the fact that people are getting things built with it, but I also feel it's big and large. It's big enough that we get to criticize it a little bit. We get to inspect of the hardships there from an API design standpoint, because it's I'm trying hard to be nice here, because it's unfair to tout something as like, oh, this is really bad, and I don't want to go that direction. I just want to look at some of the design things that I think are what make it hard to learn. So if we look at Redux, right? If we type this in, we see Redux, Redux Saga, Redux Form, Redux Thunk. So I know Thunk and Saga are intended to solve the same problem, which means that already out of the box, like Redux is meant to handle state. And straight out the box, there's 2 results that say, hey, so Redux does handle state, but it doesn't do this thing enough. We need to introduce new concepts in order to allow it to finish building this thing. So this is a warning sign to me, like knowing what these things are and knowing what this is intended to do. Yeah, that's not great. So it's a really nice site, by the way. I like this. It's really to the point. It's like, oh, cool, basics, recipes, right? Migrating to Redux, isolating sub apps. So the thing here, advanced basics, right? Like actions, reducer, store, data flow. That's okay. Middleware there. Let me think. Can I come up with some good words? I can't. Why is my computer spinning? I'm not doing anything. Hold on. Top. It better not have been that website. If it was that website, I'll get really sad. No, I was kidding. It's fine. Okay, so my computer is sort of slowing down. I don't know what it was. Yeah. So the thing about Redux is you immediately get a bit overwhelmed by words. There's time travel, there's reducers, there's actions, there's thunks, there's sagas, and even though people might be like, hey, those are not part of Redux, they are, because they're part of the daily usage of it. Even though it might be a separate package, even though the authors might think it's not, it actually, for all practical intents and purposes, they're the same thing. Coming to my point, if we look at the Redux graph images, then there's, for example, there's the reducer, which is part of a store, which gets state, which triggers actions, which go through middlewares, which has a dispatcher. I think this is Redux also. I don't know. There's lots of words. Maybe this one's better. There's just words here. What does an action mean? In itself, it doesn't mean anything. What does dispatch mean? In itself, doesn't mean too much either. So yeah, what I'm trying to say is there's a lot of words to explain. There's a lot of flow and a lot of constraints in that API built in, which if people are thinking in a particular way, which is different from the way Redux expects you to think, you're gonna have to overcome that. It's not going to be an intuitive thing. You will actually actively need to figure out what these words mean. What does thunk mean? There's a meaning to it. And some people know it, but other people are like, I don't know what it means. But if you say it's a function that returns a function, then you're like, oh, okay, yeah, that makes more sense. But in the context of data handling, that's harder. So alternatively, my alternative to that thing is, if we have an event emitter, the moment people know, oh, it's an event emitter, most people, I'd say, if you've been programming for a little bit, then the moment someone says, hey, this is an event emitter, it's dynamic, because it's JavaScript, then people immediately sort of get a sense for how that works. If you say, hey, here's a state object that's mutable, you can just attach any properties you want to it, then people will immediately be like, okay, cool. And they'll start thinking of the solving the problem in ways of emitting events and changing values on the state, which regardless of which school you come from, you'll be able to mold this into the way you want. If you really love immutable JavaScript, then what you do is you replace the values on that state object with immutable things, right? You can freeze, defreeze, or use whatever libraries you want that are probably more efficient than that. I don't know. I'm not of that school. But if you're very pragmatic, if you're just like, no, I'm from the older days where everything just changed everywhere, then you'll feel right at home. The point I'm trying to make here is by choosing this lower denominator, this very common thing, and not introducing too many words, most people immediately feel at home. They will get sort of like an intuitive understanding already with the luggage they have from prior things of how this thing works, which is great because it's flexible, and then people get to like operate instead of like forcing them in a particular mold or being like, no, you can't do X or Y. I'm saying this coming from the earlier CHOO versions, the first 3, I believe, where we definitely screwed up in API design. We were like, hey, Elm seems cool, and then you have subscriptions and all these other things. It ended up being lots of words to learn, and then the corresponding design was also hard to use, even to the point where people were like, what's the point of all this? Or, I'm writing so much code. Why am I writing so much code? And the tricky answer is to be like, hey, but you need all this code because it will guard you from yourself. And then it ended up being untrue. It just was a poor design on our side. No shade towards Elm, just for what we were trying to do with JavaScript, it wasn't a good fit. You don't need subscriptions. You don't need reducers. The discrepancy between state updates and side effects. We had effects, reducers, and subscriptions, I believe. And state itself was immutable. We figured out like, hey, you know what? Actually, state you can just mutate all you want because rendering is a snapshot of state anyway. Every value is pretty much passed by reference, and the moment you call update to the DOM and you change the value, it won't magically update the DOM too. No. You need to change it. So yeah. That's where Angular came in, because they were like, hey, you know what? Actually, you can now pass by reference, and we'll call this two-way binding, so that whenever something changes, you change a property on an object, it will also update the DOM because pass by reference. Yay. Turned out to be hard to reason about. Instead, if we just rely on the default DOM behavior, it becomes easier to reason about. So tying that whole story about API design and trying to make things intuitive, trying to make things as the sort of the lowest common denominator as possible, is this API again. Like, how can we make this as intuitive as possible? Well, in this case, we have a cache. You pass it an outgoing instance, and you give it an identifier, and it gives you a thing back. So that's about as easy as it gets. Now, the one problem here is that you don't know what to pass into a constructor, and that fucking sucks. So we'll need to think about that for a second. That's what my whole talk was about, so I didn't have to deal with that thought. Yeah. All right, cool. Let's just answer a question, because why not? Let's just not think about that part. Flashy asks, do you have Rust-specific API structures, architecture patterns that you wish to include in your JavaScript APIs? The short answer is no. The long answer is I really like the way Rust does things that you can only do in Rust. So JavaScript and Rust are very different languages. I think they complement each other real nicely. I don't think that a lot of the great patterns in Rust translate to JavaScript at all, because Rust has a notion of structs, and it has static data types, and it has very well-defined memory layout, and it has macros, which is also important. And then the final part of it is you can sort of annotate stuff. What do they call it? They call it properties, but they sort of look like decorators in JavaScript, but they're way more powerful. So what happens there is you can do really cool things with very little syntax. Probably the biggest example of this is Serta. Oh my god, I'm getting hungry, feeling a little bit faint. So this is a thing that allows you to serialize and deserialize from any data type into any other data type. Serta. Docs.rs. Oh god damn it. Serta.rs. Is this you? Yes, it is. All right. So let's take a look at this. Right. You define a struct, and you say derive serialize. This is the attribute stuff I was talking about. So you say serialize and deserialize, which is extracted from this one, right? You just say, hey, here's all these magic methods and magic properties that we want this struct to have. So static data type, which has an X and Y coordinate, can now be serialized and deserialized. Cool. So where from? Well, then you get just your custom parser. And because it has these two traits, you can now serialize any random struct to JSON, which is cool, just by using the JSON one. But you can also serialize it to TOML, you can serialize it to INI, you can serialize it to XML. It doesn't matter, you can just serialize it. But you can also deserialize some random string, right? Like this XY JSON into this exact struct. So that's really powerful, because now you have this static data type and like these magical conversions with no effort. And that's very Rust specific. Now taking that on the same thought, like that I think that is the sweet spot of Rust API design. Just define your data and attach behavior to it in a very magic-y way, but still transparent. but just you just give your data types superpowers, basically. Struct up, derive. God damn it, there's no examples of these. Documentation, creates IO, sure. Here we go. For example, this one allows you to create a full command line application just by saying derive struct opt, right? And now you call, yeah, it's like subcommands, all that stuff, right? It's still just you define your data and it just does the thing. It's really cool. And then you just say opt from args in your entry function, and then you just get that thing. And all you've done is you've defined your data, the shape of your data. And then it has validation built in, it has help commands built in, it has auto-completion built in, it has everything you could want, which is super impressive. Because now for me, it's faster to write a command line app in Rust than it is in JavaScript, solely because of this. Because, you know, I can write this real fast and it has all the validation that I could ever want. Whereas in JavaScript, it just takes boilerplate because you can't get to this level of abstraction well enough, I feel. Actually, yeah, you'll start struggling for sure. Also, this resolves the output code here is stupidly fast, like as fast as C, right? So it's just like, oh, hey, here's a help command in under a millisecond, whereas in JavaScript you need to boot a node runtime and all that stuff. So it's not even like a fair comparison in the end result, because the end result is simply better, but it's also easier to write. I really like that. Now the third thing, oh, cargo nots, iteration of this, like the third, is this no, cargo nots, no, that's not it. Cargo nots RS. All right. Documentation. So what this thing does is resources, methods, and stuff is, again, you define your data on the one end, and then you define your methods on your data. And then at the end of it, the route CSL reference. So you get your resources. So you start off with your resource, and then you say, okay, cool. Now resource user method get, and then you define your routes through this DSL thing. I'm still a little bit unsure how it works, but the idea is, again, you start off with data, you start with the shape of your data, and then you work backwards into an API, making it very, very trivial to implement. So this is, you just say, okay, cool, we have this struct here, now become this magical thing that works with HTTP servers. It's still a bit rough. It's not as like polished as the other two, but yeah, that's what I'm really excited about, because the moment you can start with data and then work your way backwards into an API, because most of REST is literally create, read, update, delete, and then you have a form of validation, a form of transformation into SQL or something like that. Most of the time, maybe you have like a few side effects in the terms of, oh, send an email. Oh, make sure this username's unique, not taken yet, right? Like they're very constrained things for most applications. Yeah. If you start from data also, you can get automatic documentation for your whole API. You can just be like, oh, here's the user, here's their REST docs. And it just works. So yeah, I think that's in terms of patterns where Rust really, really shines, because it truly allows you to start with data and then work your way backwards. Whereas with JavaScript, we'll never get there. I seriously doubt that we'll get there to the same degree that Rust does, because the doing this stuff also incurs zero overhead, because you compile it out and now you have like your very optimized, like just data first parsing stuff, and all the methods are basically boilerplate that has been implemented for you. So yeah, I'm not sure if you were expecting this long of an answer, Flashy, but There you have it. There you have the answer that I wanted to give you. Yep. Hope that makes sense. Like this is like the big part of why I'm excited about Rust, because eventually you'll just get to think about data first, which is the thing that matters most, because that means you can model your domains. You start by modeling your domain, and then the rest becomes this very trivial implementation detail, which is all you want. Like, oh, which options do we need? Here's the options. Cool, solved, right? Like, here's the docs to these options. How do we deploy it? Well, it's just a binary. Okay, cool. That's trivial. We just put the binary in the server. Cool. How do we define this HTTP server? Well, here's the shape of the JSON we should accept. Oh, yeah, that's cool, right? Oh, how do we validate forms? Well, right, it just becomes that thing where you data first thinking. So Flashy says you wouldn't think data first in JavaScript. No, it's you want to do that. You really want to do that, but there's always going to be more stuff attached to it. Because in Rust, the compiler does a lot of checking for you. If you're doing something that will result into in an invalid state, the compiler will literally be like, "Nah, I can't compile this stuff because, oh, hey, look, you have a race condition," or, "Oh, hey, look, you're casting different types," or, "Oh, hey, look, you're calling a method that can't be done," or, "Oh, hey, look, you're not handling errors," and it just forces you to do all these things. So, you know, the compiler's got your back for the implementation details, and then all you as a programmer need to do is think of modeling your data, which is kind of the heart of what we're supposed to do anyway, right? How do we do a data migration? Well, that's a big question. And then the implementation details should be trivial. And that's sort of the direction that Rust, the good Rust APIs, they move you there. It becomes less typing and more thinking about data. Whereas in JavaScript, you'll always, like, you don't have a compiler. You'll always build by trial and error and sort of write enough unit tests that this thing is now stable, right? But it's not like doesn't do this compiler first approach. Neither does C, neither do many other languages, right? So that makes this language particularly unique, and why I think the moment the ecosystem's there, it'll be really good to build stuff with, like production grade stuff. Yeah. Hopefully also allow you to move faster in JavaScript and all that other stuff. But yeah, I sort of hope that makes sense. Hey, I'm gonna grab a sweater real fast because I'm getting kind of cold. Be right back. So the idea here is I'm just gonna get the fleece sweater out of my jacket. It's like a 3 weather jacket kind of thing, which is quite nice, but yeah. Yay, jacket. All right. So what I'm thinking for now, sort of like going back from Rust and API design there into this JavaScript thing, right? Because this is what we were doing today. So yeah, we do need to do this, but we might need to restore this function that we had over here, right? Like that, because say we wanted to add more args, then we would need to apply component. Fuck, I need to find words here. Apply args along those lines. So we apply cache.get.apply. Fuck, I need to find the good words. Right. So in order to add more stuff to the constructor, you just pass some more arguments in the initial thing, and there should be no discrepancy between the two. So here, state cache component header other. This will simply like pass more stuff in there, right? Foo bar, I don't know. Most of the times this should just be like a static thing. A lot of the times this stuff shouldn't be happening at all. You should derive it from state, and sort of implicitly it passes state and emit also. State emit, right? State emit. Like this is too much boilerplate to type out. So state and emit should happen like transparent, like obscurely in the background, which I think is a good idea. And component ID that just get passed first. Cache.get apply component ID. For var I. Flash is asking, isn't the sun out where you are? Yes, a little bit. No, actually, it's kind of cloudy, but it's also a whopping, how many degrees is it? My God, it is. Oh, it's 5 degrees. My God, it was -16 this week, I believe. That was really fucking cold. 5 degrees is nice, but I was just getting a little bit chilly because I'm in the other room. I've got the window open. I also saw Emil IRC. Emil has a question about drag and drop. Is there a CHOO specific? Nope, not really. Most things should work. Cola, Senko, drag, drop. EG. So I want to recommend Mikola's module because I think I've tried it successfully in the past, which was great. Yay. I'm just gonna eat some delicious, what's it called? Paneer. Because my partner forgot to bring their lunch to work. So I'm just having their lunch. They also made me lunch, but I ate my lunch yesterday evening at like 11 p.m. because I was like, well, you know, I could eat lunch tomorrow, but I could just also eat lunch today. All right. That's pretty cool. What this does, it just you query select like a DOM node, and you just call this thing. Whenever you drop stuff on it, it just gives you back files. It's very cool. Just a callback into files. That's literally all you want. Never needs to be updated because it will forever just work, right? Function add drag drop listener. So drag enter, drag over, drop, call event, return false, stop propagation, prevent default. And you just get yourself some files. This is the kind of module I really like. 20 lines, kills a bunch of boilerplate, does all you want it to. Not updated in 5 years, will never need to be updated. As long as the web's core model stays intact, which it probably will be. So, you know, forever use that module. All right, let's build this. Sorry. Let's build this thing. It's about damn time that we get it done. And we should also probably this should be really, really fast. There we go. All right. So keys, object keys, cache, delete cache, cleanup. So this cleanup method is not ideal. It's okay. It's not ideal. So this needs to be replaced with a RU cache. Untitled cleanup. Let's just inline that for now. All right. Then we indent this a little bit and then just say like that, like that, that, like that, and then we're good. Var cache, emailer.emailer. Yeah, that's brilliant. All right. Yeah, the code looks a little bit cleaner now. So we just need to have it apply all the arguments and update the other thing to use LRU cache, which is okay. Final thing is what's the final thing? I forgot. Something. I forget what it is. So cache.get.apply. Right. No. Cache.cache. Maybe like mid. Okay, let's actually take a lib/cache. Let's take a look at this file. There's a bunch of stuff going on. No cache. Yay. Index.js. So raw. I think we just need to use this file. So I forgot what's going on. Let's take a look at the differences in this stuff. All right, so that's our index.js lib/cache, true component cache, great cache, yada 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 yada. There's a prune one, there's the render method, there's component.id. So we respect ID now. That's cool. And that's about it. All right, dope. So we respect ID. That's nice. God, if you want to see if you want to see a hack, this is literally the worst code ever. We're working around a language inconsistency. So if you want to create a new instance of a thing and you want to also apply arguments to it, so you want to dynamically create a new instance, then you need to do this thing, which is ridiculous. So you get the first argument and you call new bind.apply arguments. It's so weird. Yeah, it's not good. It's pretty bad. Yeah. Like this should be fixed in the language itself. That's sort of like the gleaming thing where there needs to be some form of dynamic, like just a solution. All right, so we're calling prune here. We can delete prune there. Goodbye, prune. CHOO component cache prototype render. CHOO component cache dot prototype dot render. Right, so there's that render. I'm just gonna call it that get. Should we call it render? Render. I feel like render is a better name. Because render is either get and create component instances. I wish we could do this for doc comments, but we can't, which is okay. So assert equal, get assertion there, we get this stuff there, we get that stuff there. Component ID, CHOO component cache render, component ID should be type function. Right. So the gist of this thing is that we store components in our cache, basically. And then we have state.cache, and then that works. I think if we just use nano-LRU, that just works. I think on line, what line? 27 or something is where we need to change some stuff. Let me just move some stuff around on the desk so I can actually see that corner over there. Okay. So we have var L, this is cache ID, var X, X unshift, line 30, fuck. Component ID, this state, emit. Unshift. Yeah. So we just get all the arguments. Args.slice. Args. Yeah, we copy the arguments and then we do something to it. And then l.render.apply l args. And all we need to do here is return L. And we don't call it to render it. We just return it. And we call this method render, and then we like add it onto the thing. All right, I think this may just be it. Where, oh, hold on, ID. So we don't need to call ID, right? But ID should be type function. ID string. Component ID should return type string. All right, and then we just add a secondary assertion there, ID, and then we add this here, and then we call that a string. Should be great ID. So we always expect a string as an identifier, never something else. Technically, it could be a symbol, but don't use symbols, I guess, here, because that's just really confusing. I don't know how to realize this. Let's just assume, hey, here's always a string. Or better even, it could also be a number. Damn it. Okay, type of ID, string, type of ID, number, that's about it. String or type number. There we go. So then we always expect the ID, and then we like get that thing, and if there's no ID yet, then we like create a new one, and then we store it inside the cache, and then we do that, and then, you know, args push arguments I, args.slice. Yeah, that's pretty reasonable. Are these arguments mutable? I think they may not need to be. Args. Oh yeah, we can just skip this stuff. args.unshift. That's cool. Because we, mix the args. Oh yeah. Even better. We can just do this here and only ever like get these args if they're in this thing. So overall, this should be like way faster. We just get var l this like cache ID, and you know if it exists, we return it, and otherwise we go through this whole thing, which is okay. So that's cool. That's cool. So now we just have our render method, which does one thing. We can actually try it out. GC will have like been borked, but it should work. It should work. It should probably work. It probably works. It probably works fine. I'm crossing my fingers that actually works, because there's no guarantees that will. But it probably does. All right. So we have everything installed. npm start. Yay. Okay. Localhost 8080. Oh, I don't care. Advanced add exception. That's okay. Great. So what are we looking at? Did our server crash? No, it did not. Okay, that's always a good sign. No crashing servers is a great sign. All right, what are we getting in the network? Are we getting anything? We're getting stuff. Response. So there's a bunch of stuff in there. That's good. I'm happy about that one. All right, let's take a look at example/index.js. So require view, all right, and then this should return something, which apparently is not. All right, are we getting any errors? Console. This is undefined. Cool. Type error. And then we refer back to there we go. Cache 9292. This.state equals state. This is undefined. Oh, we're not calling it with new. Yeah, that's what's going on. Yeah, that's okay. That's okay. So var cache is let's just call it cache here. Is a new cache. And to be completely sincere with you, we can add an assertion to this. Assert.ok this instance of true component cache. Cache should be created with new. All right. Let's try this again. Component should be type function. Fuck. All right, let's take a look of where that error is occurring. Component should be type function. All right, so we go into the, where is it? Style sheet could not be loaded. God damn, that's a big warning. This page has no style sheet. Okay, chill out, debugger. We should do a thing, pause an exception, and then we get this, and my CPU starts spinning, and then we like do one where we step out of it, step out of function, and then we should be able to find what's going on. Oh, I can eat more of this delicious paneer. That's very good. It's like made with fresh paneer cheese. I think it's called paneer cheese. I don't know. It's a cheese and paneer. Unfortunately, it's like not fresh spinach, but it's well spiced. And I'm really, you know, I think the rice, I don't know. I didn't make the rice. That's probably my only critique. Second day rice out of the fridge, not as good. But the paneer itself, ooh, the cheese, like you burst it through it. I believe you can make like paneer at home by like pouring whole milk, boiling it, like adding lime juice, I believe, was it? Don't use this recipe, by the way. Look it up yourself. But you like add lime juice to the milk, and then you like put it through like a cheese strainer, which is like this very thin like cloth-like thing, and like paneer stays out of it, and you like put it in the fridge and like hardens, and then you like clot it, coagulates, and then you got this like cheese, and you like add a bunch of salt, I think. You know, it's really tasty. I've made it a couple times here. I haven't made it like my partner has. But it's really good. All right. So assert equal, assert equal. All right. So here we look. Type of component. Assert dot equal type of component. Should be function. Step out one. Show us where this is being called. Function render. All right. Step out of it again. State.cache. All right. So what are we calling here? Footer. My God. Apparently footer is not a component. It's not a function. All right. We're using footer. We're come on. View. Jesse Skinner is just lurking while playing with my 2-year-old son Teddy. He wants to say hi too. That's really cute. Hi Teddy. I'm happy you're here. 2 years old. That's really cool. Kids are cool. All right. Oh, we need to call that render on this. That render. All right. Let's take a look at this. Teddy is also like such an adorable name. It's just, I think there's a reason why people call it a teddy bear. It's just, I don't know. I feel like those two are like forever intertwined. So when you hear like a tiny kid is called Teddy, it just instantly sounds adorable. I like it. All right. So what are we doing here? Yeah, we're trying to figure out start pre-render exports equal call stack. Start. I wish there was like a jump out stack of sorts. I don't know if we can do that. Anyway, fail. Yeah. Whoops, that might break my computer. It's not liking it. Control Shift F11. No, we're not doing that. Render apply component args. There we go. Come on, header. Dot render state.cache. Component footer dot render. All right. So the header thing is not working. This code is not working out. Jesse says, yeah, thanks. He's as cute as his name suggests. I have zero doubts. I absolutely do not doubt that. Now we're thinking of adopting cats also, which is different from kids, but I like cats. I think cats are cute. I don't know. I miss having like cute things around the house. We have plants. Plants are nice, but they're not like, not to say that you should pet kids, but kids are adorable, and I think cats are like, if you're not ready for kids, cats are a pretty decent option. So that's why I'm like looking into cats. I just want to take care of a human being, I think, or sorry, not a human being, just a being. But then I feel like cats require less attention also. You can sort of like leave a cat be for a little, for like a while, and it'll just be okay. They grow up pretty fast also. I'm not trying to explain to a person that has kids what's going on. More like it's more for me. I'm just trying to like think through like, why do I want cats? Yeah, maybe I should just leave it at I like cats. Went like to the animal shelter the other day. We're like, do you have kittens? And they were like, no, we don't have kittens. We only have like these really grumpy cats. And it was like gorgeous cat, and the cat was like just a little diva, and I was like, oh god, it's the most beautiful cat I've ever laid my eyes on, but they just seem so high maintenance. I don't know. I don't know if I'm ready for this. So we didn't get that cat. We also want 2 cats because we live in an apartment, and just having a single cat, multiple cats. So cats entertain themselves. It's easy. I grew up as a single child. Didn't have any other children around all the time. Would have been cool if there were. Would have been really entertaining probably. Anyway, code. Yeah, so this thing is saying CHOO component cache.render. Component should be type function. So we should actually in view console.log component and type of component. And we can just re-rendered. Cool. Blanco reload scripts. Type function. Dope. Wait, what's going on? Component should be type function. CHOO component cache.render component should be type function. So it's not right now. Component. All right. This looks like a function. What is going on? Why is that error being thrown before like log hi? So that's definitely a function over there. Console. All right. No debugger. Just this. CHOO component cache.render component should be type mother. Where is the wonderful go-to bust up when you need just a sharp parallelize to instantly spot the error in your code? I think they're at work. That's what I think they are. So now we're like, now I'm stuck with trying to debug this. Hey, if anyone in chat spots our bug, please do not hesitate to point it out. Like this is the exact type of thing where Rust would save my butt, because we're referencing something that's not there, and that's an invalid state, and Rust doesn't allow you to go into invalid states. So that's pretty useful. Hey, all right. CHOO component.render assert equal type component. Component should be type function. Sol.trace component. Type of component, and then component. All right. Reload. A prototype start. Hey. All right. So apparently we're like doing async logging or some stuff, right? Because one caught exception instantly. So we're getting cache there, right? Fail. God damn it. All right, I think it's Chrome o'clock. we're gonna put out Chrome. Chrome unstable. Localhost 8080 advanced. That's fine. All right. I feel like there we go. For some reason, Firefox is screwing up here. It's showing this first and then that second, and that should not happen in that order. It should happen in this order. And this also gives us a thing, and async stack traces, which is everything we ever wanted. And it doesn't force me to like, see, it just stays in console like it should be. Start CHOO pre-render render. All right, so here's the render function. Return cache, render, apply, component, args. Ah, that 1 should be a 0. Lib. We aren't. There we go. F1 R0. There we go. And now please work. A different bug, I think. Assertion error. String expected something uncaught. Okay, stack trace. No stack trace. Stack trace. Render. Oh, that's still a 1. Oh, okay. We need to reboot our server. There we go. And now, oh, what? Did we just mess up? Okay, I guess we messed up. Come on. Go sup definitions for index.js 27. 27 0. There we go. Cannot read property header of undefined. Okay, different error. That's okay. True component.render. Cannot read property header of undefined. Why are we this.cache.header? This.cache. Huh? Oh, so this.cache is not a thing? Why isn't it a thing? Why is it not a thing? That's weird. Oh, we should also probably, should we use symbols or something? I don't know. Hey, you know what? I'm gonna take a break. I'm gonna take a real quick 5-minute break and go to Lou and wait for a second. Yes. We're really close to getting this. I think we like need 45 more minutes, and then we like have a working version of this, and then we can like PR and whatnot, and like have people review this, and just continue that. All right, bathroom. Catch you in a bit. Hello. Woo! It's Comrade Rihanna. Yeah. Potato camera. Oh. Oh, this is cool. Oh wait, you got the whole like setup also. Nice. That's cool. I really like this. That's cool. How's it going? All right, so I feel really good. I really need to go to the bathroom. So just good. Pour some water and ready to debug this thing. Excited to debug this thing. Cannot read property header of undefined. Oh my god, they're rendering on this thing so bad. Maybe it's because we upscaled, and that's weird. Maybe it's not. I don't know. I don't know why it is. Rendering text is weird. So it says cannot read property header of undefined, which probably means in this case, if we look at this scope, actually let's just do this. Pause on call exceptions. Then we can look at the scope, and then we can say this dot header, this dot header. Actually, this dot header. Actually, this class call check, property object get prototype of something. Yeah. All right, this is really interesting because I don't know what's going on here. So we're passing it through Babel, apparently. Something ID is header. Something interesting. Because this is a prototype, and then this should definitely be this cache. That annoys me a lot because I don't know what's going on here. I really wish we didn't have the Babel stuff ever. That'd be really, really nice. Args, unshift, like it's such an ad hoc compiler. Everyone's like compiling stuff anyway. I'll be happy once we can like properly compile stuff. But that's a rant for a different day. So we are getting through here. We are getting through there. This dot is instance of CHOO component cache. CHOO component cache is not defined. Fuck. This dot prototype. Nano component. Oh, interesting. So apparently in this scope, it's changed the prototype to nano component, which is a special class of fucked up because we're calling it from render. Oh, that's intriguing. Don't know why that's happening. Cache.render.apply. Oh my god, right. So cache.render.apply component, whereas we should be calling it from cache, I think. Possibly. There we go. That is. Lovely. /other/home/other/home. I guess that's working. That's working fine. That's really good. I can reload this even. All right. No more errors. No more errors. Just weird traces. Console example/view. Oh, cache. Console. That's example/view there. Oh, we're probably rebuilding a lot of stuff. Let's just kill that and go back here. And this is great. And then that works. And then we got the whole thing, right? Redo API. All right. So now we have this whole thing. It's a lot simpler, which is nice. We also get on the thing, say the cache.render. Whenever someone asks for render, we can just be like render.toJSON equals function. Then we return that. I think I think this should work. So it just returns. Actually no. All right, let's do a little experiment. Var foo equals that. Foo.toJSON equals null. JSON.stringify foo. Right, dope. Okay. Like that. And that should work. We add a comment here where we say when the state gets stringified, do nothing. Make sure state.cache is then stringified to all right, that's good. To JSON. All right, cool. Whew. Okay, so we got most of it done. Now we can focus on getting nano in. Nano LRU. How's everyone doing, by the way? Everyone having a good Monday? I'm so very much. I'm feeling kind of sleepy still, but I feel sleepy every single day, unless I've like worked out the day before, which I did, but I don't know. I think my attention span is just pretty low. In the last couple of weeks, I was a little bit overworked. I feel I'd done like too much work in the weeks before, so I was like just not able to do a lot. Quaker763 says not bad. It's near Tuesday here. Cool. Where are you located? Probably like Australia or something. Close by there. Japan? Must be like 10 hours out ish. Aussie. Cool. I'm going to be visiting Melbourne 2 weeks from now. So if you're like around, that'd be cool. So Monday or two, just reverse engineering the Age of Empires 2 random map generator. Of course you are. What's it written in? Is it like a C project, but you're like turning it into JavaScript or something? Quaker says, I'm currently making my Linux laptop look like Eric's. I don't know what Eric's is. Curious. Eric's is a discontinued operating system developed by Silicon Graphics to run natively on their MIPS workstations and servers. Cool. That's pretty dope. Oh, cool. You're gonna be at JSConf? I got a free ticket somehow, which I'm pretty like stoked about. It's in decompiled C++. Holy shit. Of course you're doing like something ridiculous. I expect no less. Wow. That is also really cool. Decompiled C++. God. Sounds pretty intense. Probably have uni. All right. I like that people have like cool projects. All my projects are usually like boring web stuff. Let's take a look. So we need to replace that with an LRU cache. Cache ops or something. I don't know. I'm reversing SH3 at the moment myself. What's SH3? Smite Heroes 3? Damn, I have no idea. I've played a fair few video games in my time. Sounds interesting. Oh, Silent Hill 3. Ah, sick. That's sick. I never played them. I believe they were like PlayStation only back in the day. Or at least I thought they were. I didn't have a computer for a really long time. And also I didn't like horror because it always scared me to like shitless. But sounds pretty cool. I don't know. I've never even tried to reverse engineer anything. Just sounds so cool to do. So I have to name the most relevant functions. Oh, you need to do those PC ports. Cool. Sick. Just using Vim to reverse engineer Age of Empires. Yeah, why not? I'm just gonna eat cheese while this like goes on. Alright, so we have nanocodes, right? Oh, damn it. Or was it? Nano LRU. A simple LRU cache. So it's get, set, remove. Keys length clear. All right. So I wonder what Brett set this thing to. LRU package JSON. It only has class cache. All right. So class cache has cache a class instance by key. Interesting. And this is using nano LRU, nano assert. All right, so still no LRU. LRU 100? No. LRU. Does this thing have an LRU in it? Probably. Next.js, class cache, super GC. Ugh. I can't work with this code. Has clear new will GC unshift this index of type or key. It's pretty complex code here. Arguments length. Where's the LRU at? LRU equals 0. Top level defaults. The default is 0? Odd. So it doesn't cache by default? I don't get it. All right, let's say 100, because why not? For LRU, oh, we could just define LRU on the other thing. So we could just remove this part of the code, because we'll have auto clearing code. On idles, defined but never used. Okay, so go to package.json, we can remove on idle. I'm manually renaming relevant things in my file. PB file. Oh my god. Both of you are doing mad things. I'm impressed. It's really funny also. Like, who does that? It's pretty cool. All right, so I need to replace our cache instance here with a LRU thing. Corker says I have way too much spare time. Shit. working on a grant is also kind of fun. It's basically like infinite spare time, but that you need to dedicate it to a particular project. Just, yeah. I wish I could like reverse engineer. I would like to learn that at some point. I have like no practical use for it yet, but it just sounds really cool. Like, oh yeah, I can reverse engineer things. I think one of my friends once reverse engineers a banking app to figure out how the API worked, so you could like reach it from the command line, which was kind of fun. I knew nothing before I started, so yeah, it's fun. I have like a friend who works on this thing. Used to work on it. Radare. But then I heard like bad things about the community later. Oh yeah, I'm I686. No, I'm actually trying to like understand a little bit about the Intel assembly. But I heard that this assembly might be like better to write. It's fine, it keeps you up. So this thing I also found the other day, which was really interesting. The Godbolt editor, which is a compiler explorer. So you can just like have your Rust over here, or you know, any other language. In my case, Rust. And then you like convert it to these instructions. I sort of understand what they do. Just, you know, there's a lot of reading here. Copies the second operand, source operand, to the first operand. The source operand can be immediate value, la 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 la. That's really interesting. Yeah. Like this whole thing is super cool. You can like do all this shit. And it just gets like wild. Like, what is going on even? Libraries. No libs configured for Rust yet. All right. Clang ASC output. Oh, ASC output is not supporting Clang. Damn it. GCC tree RTL output. Ah, damn it. That's copying the value in ED to a pointer. I don't know what that is. But yeah. It's pretty cool. I have nothing more to add to this. I'm a third year engineer confused. I mean, all the assembly lol. Oh, ECX is a this pointer? Oh, where are we seeing ECX? ECX? No, damn it. Okay. EDI is a register that contains a 32-bit value. Cool. So we're adding two 32-bit values. Oh, actually. So what happens when we change that to I64 and I64? I wonder if these exist. These exist, right? Yeah, they do. Oh, cool. So then we have RDI and RDI instead of EDI. Oh, that's cool. That's cool. All right. So we just add those. If you switch to C++, you might have a class example. Interesting. All right. Let's look at this. Oh, this looks so much cleaner. What the hell? That's fucked up. Why is this fewer commands? Rip no classes. Shit. So this num times num. What? You can just define int here? That's sick. EAX imul. Why is that different? Oh, damn it. Right. Yeah, that makes total sense. EAX is 32-bit. So apparently num int C++. Right, fundamental types. Sign short int. What does int mean? Int. Right, okay, C++ standard. At least 16? What the fuck? It has like no defined. Okay. That's weird. It's weird. Okay. So this is weird to me that C++ has this, because int just has like a sort of extra meaning to it. It's like a variable for size, which is, I don't get it. Int is machine dependent, but usually 32. Yeah, exactly. Like, it's not giving you because C++ can target old systems, so int should be 16-bit. Yeah, so I get that, but I'm like, why is it not like explicit? Why isn't it like I32? Oh, how do I do int 32? Damn it, I shouldn't have closed that. Fuck. Okay, there. How do I do that? Integer 32 or right there we go. Data bus size. Int32t. Fuck. Int32t? Unsigned integer? No, it doesn't do that. Meh. Yep. But this assembly output is so nice. The physical data bus could be 16 bits. Interesting. Oh yeah. Yeah, I can't. Headers. I don't know how to add headers. Standard lib? No, which ones? .h? No h. Use the -t type defs. C++ type defs. Oh, standard type.h. Thank you. Skip. What was it? Include standard type.h. Pretty please. Wait, you're compiling in browser? No. We're using Godbolt, which talks to a server. Don't worry, it's not that insane. Be crazy if they were like, yeah. Don't worry, we have like everything here. All right. What's the error we're getting here? No such file or directory. What are C standard type? C standard type. Also no. I'm sorry everyone. No cigar. I was looking for a C++ compiled WebAssembly yesterday. C standard int. C standard int. Oh, and then yeah, we can remove the edge thing, I believe. Right? Ah, sick. Okay. And then int32t. Oh. int32t. Okay, that's exactly the same. And then we do int64t, and then we just get a little bit more. All right, so it changes to 8, and then we get one extra move command. Cool. Handmade Hero guy basically type defed all of his variables on his project. Tedious, but simple, it works. Yeah, sick. Rocksheep's asking, what's happening here? So we're working on JavaScript, but we got sidetracked because people were talking about disassembly of stuff. And now we're like typing C++ in the browser thing to figure out what assembly comes out of it. So keyword means quad word, which is 16 times 4 bits. Interesting. 16 times 4, that's 64. Oh, sick. Yeah, it makes sense. So if we then turn it back into 32, then we get that. But what happens if we turn it into U in 32? Exactly the same code. Sick. All right, so it just gives us a square unsigned int. Oh wait, so assembly has types also? Wow, this is so cool. This assembly makes a lot of sense, right? But then if we like go back to Rust, this assembly makes so little sense. I don't know what's going on here. Ah, yes, of course. It's been a while since I've seen assembly. Yeah. Moves a value from the stack at RBP base pointer into EAX and use imul immediate multiply to multiply values. Sick. That's sick. Interesting. So here we have a function example colon square. Push RBP, move RBP, RSP. Immediate multiply, set O, which is set output, set something, and then tests it. Wait, so what does test do? Computes the bitwise logical end of first operand, source one operand, and the second operand. Sets the SF status flags according to the result. The result is then discarded. More information available in the context menu. I don't know what that does, but it sounds like it validates if something, whether or not something works. Interesting. JNE, and then, oh, okay. So this is the extra stuff, right? This is the good stuff. Because if we then change it to I64, then we get about that one compile, I64. Then we get that stuff back out, right? The code that we had before. Right? This is about the same. But then Rust, so the blue part is the overhead of setting this stuff up, which is pretty trivial here. And Rust has a lot more stuff going on here. So apparently this whole thing goes on, and this actually corresponds to that. Zero flag is zero flag. That's why Rust is shit. Oh, hold on there. Nah, I get what you're saying though. C++ master race. Eesh. Oh, you fool. No, I really like Rust. Like, if we compare this to JavaScript, where I'm like, from, that's just like, oh god, this is a pro Rust stream, as in not professional Rust, but we really like Rust. Wait, why does Rust convert to 10,000 times the commands? I think. So Rockshape, I think the answer is there's stuff like this, where it's like checking for stuff. And then what does this do? Checks the state of one or more of the status flags in the E flags register. And if the flags are in the specified state, performs a jump to a target instruction specified by a destination operand, condition, la 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 la. Oh god, I'm not sure what this does. But LBB 0, I don't know. I've seen that hazard is good for OS dev. What's that overhead anyway? We should just write down bits. Interesting. So Quaker, what do you mean by how the CPU keeps track of the state? I'm not sure what this state means in this context, because I've never thought of how computers work. Nah, kidding. I know very little about the processor. I've done like some very basic assembly, but like not Intel assembly. Jump if not equal. Oh, cool. Ah, sick. So there's this built-in like panic stuff. Yep, the macaron. I think what you're saying is spot on. It just safeguards against overflows. Yeah, there we have it. So here we go, and then generates an invalid ops code exception. The instructions provide for software testing to explicitly generate an invalid ops code exception. Okay, cool. Right. UD2, right. So it just guards against overflows. Whereas here, we can go into fun little Jenny. No, Jenny is like an if. Oh yeah. That makes sense. That makes sense. But here, like nothing happens, right? It's just we pass too much in there, and it'll just like be whatever. Although on the other hand, it does have this thing. I don't know if this means anything. It might just be like a name. Yeah. I think we're on the same page. So this is guarding against stuff. That's good. I want that. I don't care about performance in that case. Like having defined overflow behavior. Yes, thank you. I think we just solved the mystery. It's slower, but it's safer. I'll have it. That's about the deepest I can go about this. Okay, Quaker saying more on E flags. The carry flag occurs when a borrow happens from the most significant bit of a math operation, meaning went into bit 33. Oh, I don't know what that means when to borrow from the most, if we're talking about 32-bit values. So does that mean we overflowed and then like the carry flag happens or something like that? I'm very rusty in that regard. Cool. I like this a lot. Ah, interesting. E flags. E flags. E flags. Right. Ah, that makes perfect sense. So we check, hey, did we overflow or are we going to overflow? If yes, then jump there. Along those lines. And it basically rolled back to 0. Sick. That's really sick. Okay, this assembly is starting to like make sense. And we just check like the index of the thing or something, and then we like roll it back, and then we like get the thing, and then this makes me happy. We just figured out why this is generating more code than C++. Thank you. That's been really useful. Cool. So apparently you execute commands and the command sets some status flags, just like in shell, I guess, where the variable of return code, which is what is it? Fuck. This one is persisted until the next time you call a command that sets it. So you just get to like chat. So running a command sets those codes. For example, where is it? Here or something. It sets like a flag, and then you check the flag, and then the cool flag's okay, and then you can continue again, and you can check the flag again, and continue again, and check the flag again. Interesting. So here we basically execute twice. Once to make sure that we don't overflow, and then we execute again to actually, you know, make sure that works. I feel like the highlighting is a little bit off though. So G and E will check the 0 flag, etc. Sick. That's really sick. So in a way, it kind of feels like shell, I guess. We're really sidetracking from this JavaScript thing, by the way. But it's cool. I think it's like important to have like a mental model of how all this stuff works. Yeah, kind of. I know, right? Implement component location I 686 assembly using CHOO done. What do you mean? What do you mean cache? We'll just use registers. Component register. You can find all the instructions do on Intel site. Yeah, I might just like read that. Intel assembly. Introduction to x64 assembly. Okay, there we have it. We can read this. But like sort of not joking, might end up like actually rewriting CHOO and Rust at some point within the next 5 years. I don't know when, but probably. It's like worth it. I think eventually. We're getting pretty close though, because WASM pack. The Intel CPU manual is like 9,000 pages long, mind you. Yeah, God. So this thing is going to be pretty awesome. Just say like feature proc macro, and then you include the prelude, and then you just get like external functions and bindgen stuff with the Rust vdom thing. Yeah, I agree. So it's going to be really cool because they're going to be using WebIDL most likely. There's a big chance that they're just going to use WebIDL definitions, which look like this kind of, what is it? Interface stuff. and convert that into automatic bindings into WASM for Rust. So like, oh, let's get standard web in here, and then you like have the full DOM API available to you, which is generated from all the WebIDL definitions, and then you can like just use it. And like, I mean, if all the hardship you need to do is WASM bindgen and say no mangle on all your external functions, that's pretty good. And you just call standard web and you just get the functions from there. It works. That's gonna be really cool. Hey Dan, welcome. No prior knowledge of exit. Okay. We need to not do that. This is way too cool though. Thanks for the lessons. Also, I'll be putting this on YouTube at some point. So if anyone like wants to watch it back and learn assembly with us, you can do that. All right. We were doing something. I think we were like gonna use an LRU cache. New LRU. No worries, mate. God, I can't do an Aussie accent. Channel? I'll sub. It's just like my name. It's like my Twitch channel name. I don't have like a fancy identifier, but I think if you like Google it, it'll like show up there. I try to put archives on there of streams. I sometimes forget. The other day, what happened? We had a power, like my computer ran out of power, so like half of the archives, like I couldn't record. Hope that sentence made sense. Okay. We need to use nano LRU. Seth Thompson. Here we go. New LRU 200. Right. LRU equals LRU or vim lib/cache. LRU is not defined. Var LRU is required. Nano LRU. No, actually, it doesn't look good. Looks better. Right. Okay. LRU, new LRU. And then we go into this stuff. And then we have this cache. And then we do this cache.set and this cache.get. And then, yeah, that's about it. And you call this cache.set. Set ID L. This cache.get ID. I think that's how it works. And hopefully this never throws. So let's just double check. Get, set, unlink, peak, set. Where's get? .get has own property. Well, we never throw, so that's good. All right, dope. Let's see if this works. God, I just want to do assembly now. It's like way too interesting. Sort of like an ongoing theme in like all the computer stuff that I've done is I always want to know like more about computers, because it just seems so damn interesting. So like if you're like, I know how computers work, then I don't know, just feels empowering. The Storm Crow is asking, are you using Ubuntu? And the answer is no, I'm not using Ubuntu. I am running Arch. That is not to say that Ubuntu isn't a perfectly fine operating system. It's just that Arch is a bit more flexible if you really want to customize things or learn about how Linux works. So I had some free time and I took the plunge into actually, how do you say that? Biting the wood, going through it. I don't know. I just got through and then ended up using this. So that's pretty good. Yeah, mate, you can't. It's really easy to learn. Yeah, I got a feeling like it might be, except when. I think my policy for assembly will be I want to be able to read it to a reasonable degree. I sort of understand what people are doing with registers and with flags and with move operations and like the gist of it, and then just never write it. Just because understanding how it works is I pretty much exact sudo pacman SYU. Yeah, that's funny. I once aborted while doing that, and I had to like restore parts of my system, like roll back from like recovery mode, because apparently my bootloader init ramfs was like corrupted. Don't recommend that. In other news, yeah, don't hit Command C when you're like upgrading your system, or power outage or something like that. All right, so this is working exactly the way we wanted it to. I think that's pretty good. That's pretty great. Jalapeno SD says, I would switch to Linux, but it doesn't have proper software for my Logitech mouse and keyboard. I don't know what you mean by proper software. I am using a Razer mouse, a Razer keyboard. I have another keyboard that I use. Haven't tried my Apple keyboard yet. I have a Logitech webcam. And all of them work flawlessly. So I don't know what software you might need for your operating system, but they just work. The Stormcrow is asking, do you have Vim and Mozilla both open on the terminal? So the way this works is I'm using a thing called i3, which is a tiling window manager, which means every single, like usually you're used to floating window managers where you float windows over one another. In my case, I'm using one that auto layouts things based on constraints. So for example, I can be like, oh, please resize this thing, right? Or here's workspaces. You might not be able to see it, but right? So it multiplexes the thing and it opens the thing. And here's like, for example, on the left, there's this little Twitch thing. There's a little video thing, and then Mozilla and this one are docked together in one thing. Requires a bit of exercise, but the answer is no, it's not in the same terminal. It's using tiling window manager to do this. You should be able to find a replacement package. Logitech made Logitech gaming software for Windows. LEDs, DPI, and macros. Oh yeah, that's true. So on my Razer keyboard that I'm using right now for typing, for programming, I can't change all the stuff either, but if I connect it to a computer that does have the software, you just update it. You just change the settings, and the settings are persisted on the board itself. Yeah. So Stormcrow asked, tiling window manager. Yeah, it's i3 on Linux. Oh God, where's my internet? No. Just look up. It's literally called i3, and that's all. Improved tiling window manager. Right, you should be able to find like some more if you like look into it. There's a few. i3 is probably one of the more popular ones, which is convenient because that means there's more stuff out there for it. So if you like ever get stuck, there's most likely an answer for it. Okay, what we've got? Use LRU cache. All right. I think we can PR this thing because we got it. We have it. Oh, we need to update docs. Documentation. README. There we go. Article body. npm.js package tile. Oh God. Of course Dominic made that. He also has his own editor. Holy shit, that's actually like non-trivial to make. Oh, the Stormcrowd's asking, which combination are you using Vim with? Oh, I'm using tmux inside of a terminal. So the terminal is called Alacrity, and yeah, I'm using tmux inside of it, so I can like switch sessions like this, which is really convenient. Oh god, I forgot that. And why I'm not using Visual Studio Code, because I'm used to Vim, and Visual Studio Code requires a different workflow. I like Vim's workflow because it's all inside of the terminal. You can't shorter assembly if you use num wrapping mul num because that doesn't do the checks. Interesting. Is that Rust? Oh, wrapping mul Rust. Oh, interesting. That's pretty cool. I know what this does. Binary for wrapping. Provide intentionally wrapped arithmetic on T. Approach like U32 is intended to never overflow, and some debug configurations overflows detected and results in panic. While most arithmetic falls in this category, some code explicitly expect and relies upon modular arithmetic. Ooh, that's sick. Interesting. Thank you, the macaron. I did not know this. This is really interesting. So you can actually make it unsafe if you need to. Wrapping.mul. Cool. Wrapping.mul. Come on, jump to the page. All right, let's make a pull request in the meantime. I feel like my internet is like lagging down for some reason. All right, so we got this. We renamed it to ID, cache, new cache. Oh yeah, we need to update the docs. That's what's up. All right, cool. Wrapping modular multiplication, compute self times RHS, right-hand side, wrapping around at the boundary of the type. Cool. I am not sure what that means. I don't know what wrapping around the boundary of the type means. But apparently it's needed. Oh, sorta half get it. Okay, that's pretty cool. All right. Let's update these documentation things and finish up the PR. And then I'm gonna close the stream because we've been going for 2.5 hours. But not yet. Render header. Wrapping around means max in plus 1 equals 0. Oh, sick. Okay. Yeah, that's cool. So it's like a modulo for max length. Sort of. That makes sense. That actually makes sense. And then for some reason I can check with flags whether or not something has been wrapped around. Oh, that's really cool. So if assembly by default just always wraps around, right? Does it do that? Huh. I thought like assembly overflowed if you just like wrote max in plus 1 into a register, or yeah, if you just wrote that, you would just get like over the thing. Yeah, pretty much, but it happens automatically because you just lose the bits. Yeah, that makes sense. No, I thought the behavior was much more volatile than that. It sounds very constrained because you just say, well, assign this much space, and if you write over the space, it just like writes into like undefined stuff, and it's like, oh god, you should have just checked. But in this case, what it then does, it just like loops back around. So I wonder how you like access undefined memory. It'll let it take. Yeah. Nope. All right. That's where point is. All right. Oh, I sort of get it. I think I get it. So that's where pointer is. Buffer overflow. Interesting. So we do Rockshape's asking, so what are you building here? So the main project I work on is this web framework called CHOO, which is for front-end websites. And we're working on a component system because we're like a year overdue on that. Basically speaking, sort of, to put it bluntly. State cache. Integers wrap around, but writing to a bad pointer is a crash. Interesting. But so, sort of asking through here. How do you reach undefined memory? How do you say for some reason we get like access to like do stuff? Actually, that's sort of answering my own question. If you can like, if you have like a dynamic pointer, you can somehow access it. How can we like overflow a buffer to reach memory, other people's memory, like other not people's memory, other programs' memory? Because I know if you like overload the thing, but you do that with pointer, I don't get it. So you just modify a pointer so you like jump into like that undefined memory or that other program's memory. That's the only way. What's a buffer overflow then? I'm sort of starting to question myself now that I know that it wraps around. I'm just like, what? Set a cache header, and we call this header. Set articles map. Well, Rockshape says that's pretty cool. Oh, happy you like it. Glad you like it. Article. Yeah, we can just remove this. Well, you could do something that somehow spits out a whole heap of bytes. A buffer overflow is when a buffer exceeds its length. Right. But didn't we just say that when a buffer exceeds its length, it just loops back around? Because oh wait, or is a buffer right, so a buffer is just a pointer into multiple bytes. It's not a thing in itself. It's not like writing an I64 to an I32 space where it just loops around. It's actually a pointer into the bytes, and then you overflow that pointer, and now the pointer keeps on pointing forward, and then you access different bytes. I get it now. I get what you're saying. Yeah. Yes, integers wrap around, but getting like a string, you move a pointer forward in time, right? You move every single character, which is a byte, or whatever. It's a character. Words. You read the byte sequentially, and then you like just keep on reading into like undefined or into the memory next to it, which is a buffer overflow. Buffer associated with that. Yeah, good. How Spectre works by abusing what happens when it doesn't check permissions. Yeah, that makes sense. Yeah. I get that part. I got that part. Yeah, makes sense. Header X-Force P says it does check permissions, like the Spectre thing. I think I have like a good sense of how that works. I can't see who's online. State.cache, state articles map. Really interesting. Article.id. render article. Something like this. And we like need that one there. I hope. You got to read all the random bytes. Just keep going until you reach the end of the drive. Kernel pages ring 0 permission bit. That's funny. All right. So we have this almost, now we have that, and that works, and then we just call that render on the end of it. Render footer, dot render, and inside of render we call it static cache there. Comment Rihanna is asking, does static cache header also need a render call? And the answer is yes. I think the stream has a slight delay, but it does. We're not doing any of these things over here, so that should be okay. All right. What are we seeing here? Itself's not a bad thing, but yada 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 yada. I'm not following there, but that's okay. I think it's talk amongst thyself. All right, so that's okay. All right. Let's see if this works. Please work. Please don't crash. Please don't crash on me. I think it works. Yeah, cool. Oh, we should like preview the thing, probably using VMD. I like how people are talking about assembly in the chat. I'm just like reading and I'm like, oh, I'm learning things. That's really great. I'll just sit over here and write some JavaScript. Don't worry. What does DPL abuse mean? Slayer Darth, great styling. Oh, thanks. I think it's about me though. I think probably. Yeah. Or about DPL abuses, because that's some proper style right there. All right. This all works. Oh yeah, we said we'd preview this thing. This might make my computer spin, but hopefully not. Oh yeah, I've still got like some lunch here. I'll just kick back and read chat. Interesting. DPL are the permission bits on the virtual memory page. That's cool. Is that the kernel ring 0 stuff you were talking about? Comment Rihanna says get 304. They should do cache control immutable too. And while I agree with you, I don't know if we don't have like a browser cache for command line tools. So you're right, but yeah, they should be. So comment Rihanna helps out on CHOO, which is really fun because I think they literally read all the comments on all the projects. I was explaining how to use cache control immutable to someone in an issue today. which I think is what they're referencing for everyone else but them in chat right now. I guess I need to check for new versions. Yeah, but in a way, I wish they would just submit the whole manifest like in a single go instead of like a single request every single time. Just like, here's the manifest. Are there any updated versions? And it sends you back a manifest. And it's like, okay, cool. And now get the individual ones. Oh, I saw it on Twitter. Fuck, I forgot. I was way more impressed that you read all the thing because I still stand by. I think you actually do, but perhaps not that fast. Maybe. All right. Anyway. VMD. Yes. I don't think I have meltdown. Okay, state cache, header, dot render, article map, yada yada yada. I think this is good. Article title. I think this is much more palatable now too. Where yeah. We should probably extend this part. Like this. Constructor, name, state, emit, super name. This that emit is emit. Like that. That's pretty good. I like this. This is good enough. So for all your easy components, this just works, and this just works, and then it's now an immutable thing, and that also just works. All right, I'm pleased with this. It's pretty straightforward. Here we just literally map over articles, and then we just get all the articles out of cache, and then we call render on them, which how it should be. Set cache, footer, render. Yeah. Brilliant. That's literally all we wanted. Literally. All right, that's good. So we've updated docs. Let's push the docs. All right, then we got that. And then we do this and reload this. And we don't even like need to reload it, but I just want to see it. And GitHub doesn't do CSS pre-render on the server or critical CSS inlining, which is why the whole thing reflows, but we'll forgive them. Chrome's a bit better about it. It just doesn't render until it like notices that it's got some CSS. Here it like starts rendering straight away, which for most sites, I guess, doesn't work out well. Static ID, do we even need that? No, we don't. Component ID, there we go. They should just use Bunkai roll eyes. They should. Actually, a fun thought exercise is how could we build Bunkai in Rust? I think the answer is more feasible. I still haven't figured it out, but I think the answer is more feasible than you'd think because Firefox has all these web things, like like CSS parsers and font things, and we might be able to at some point. It's the JavaScript pre-render that will really fuck us over. But then sort of thinking about, do we really need that? Or can we just like shell out to Node if it's there? Along those lines. I wonder. I really, really wonder. Simplify component example. There we go. X4SP is saying Meltdown expected both work because of stuff left in cache. The issue that was discovered was that you could observe the state of the cache after speculative execution, which was not supposed to happen. The fix for Meltdowns to force the CPU to flush the memory. It's more complicated than that. Because doing a switch from user kernel spec. Okay, cool. Yes, I'm happy you're thinking this is really interesting. Been playing around with make my own browser file until pull strings. That's also really cool. So while I really like pull streams, they're really not efficient. But a Rust browserify, yes. Please build browserify in Rust. That would be so sick. Like literally, if we could like take all of our transforms and just put them in Rust, everyone's like, oh, but parcel's so fast, and we're like, no, but you know what? You can't get faster in this, pretty much, unless we fix algorithms. But in terms of overhead, we just wipe out a whole bunch of it. That would be really, really cool. Also, with like WASM pack and stuff, like generating bindings is now becoming like easier. Like by the end of the year, it'll be like super trivial for sure. Like perhaps like in a couple of weeks also. Quaker763 is asking, what are the benefits of Rust? So the question always needs to be answered from what is your background? In the case of me and Comrade Rihanna, I think we're like both mostly JavaScript people. So then the benefits of Rust instantly also become, for a large part, the benefits of C and C++, which is performance. Because you get to like access low-level APIs, and there's less overhead, and that's pretty cool. But in the case of Rust specifically, oh my god, yes, also please that. Like all the transforms that we have, we could do this. It's how Webpack does it, by the way. Yeah, anyway. So in the case of Rust, the thing that I personally really like is that your compiler does a lot of the lifting for you. It looks at like, oh hey, here's an invalid state. That's not going to work out. One compile, and then you're like, oh okay, sure, let's handle that state. And up until after a while, you're like done, and there's like no more invalid states. You might still get infinite loops or other bugs, but like the 90% of bugs has been taken care of. That's something that I really enjoy, because if you're working towards building software that needs to last a very long time, you probably want to guarantee that you want to put in the extra effort to reduce the amount of bugs. It's sort of like a question I've been having, like, how do we build software that will last us a decade? How do we build a service, like a simple logging service, that will last, that will just work for the next decade? In JavaScript, that's a hard question to answer, because a lot of it will require like reiterating, and I don't know. But if you build it like in a static language, like using low-level APIs and stability in the thing, it actually you have a higher chance of achieving that. And I'm starting to become really interested in that. And yeah, also like Comrade Ryan is saying, Rust has really nice people in the community. Yeah, they're gonna have a Rust Hack Week like in 3 weeks from now, the end of March. So there's a bunch of people coming here to Berlin. Ashley and Steve will be here, so it's gonna be like fun. Yeah. So that's like what's in it for me. Also, the thing that Rust is really focused on, which makes it extra cool for JavaScript people, is that you can compile to WebAssembly, which means you have like WebAssembly is basically like a runtime for assembly. So you just have very portable assembly stuff and written in Rust, and you just interface directly with stuff. So that's pretty exciting. And for stuff like Browserify, which doesn't require access to any I/O, it's just like a parser with like multiple steps. Converting that to WebAssembly is actually quite feasible, which is cool. All right, I think we just need to push this and PR this, and then we're good. Proposed. Use LRU cache. Use LRU cache. What's the other one? Add a .get API. Update API. No longer implicit render. along these lines. And I am going to assign comment Rihanna. I hope. Can I do that? Go to, oh fuck no, it's just my project. I'll post this on IRC. See if npm test passes. Probably does. Yay. All right, CHOO. Slash made a PR. Using 0 to work with. All right. Oh fuck. Actually, I think I made a bug. Yeah. State emitter app. LRU, LRU, LRU. So we have new cache. LRU. LRU. Passing LRU. Like that. All right. All right, all right, all right, all right. Oh, third change we made. Sorry, I'm just mumbling to myself now. Is remove third argument in functions and it's with state.cache instead. Ping Tornquist. All right, I think that's about it. I think this is like good enough to land in CHOO. Actually, there might be like a few holes in there, which is why code reviews exist. But I think we did some really good work today because we've been putting I've been putting this off for a while, multiple months, probably. So yeah, this should hopefully allow us to make some progress, which I'm excited about. Yeah, I think that's about it. That's about what I wanted to do on stream today. We talked about Rust, we talked about assembly, we got some JavaScript done. It's 3 p.m. here now. We started when did we start? 3 hours ago on the 2nd. So yeah, it's been great. When will I be streaming again? I don't know. I have no idea. Maybe another time this week. I'll announce it on Twitter again. Yeah. Hey, thanks everyone for like the first of all being here, and second of all for like the great explanations of stuff. It was really entertaining. Yeah. So yep. Hopefully see you. Hopefully see you again soon, sometime.